The Northern Lights are one of the 7 natural wonders of the world, and even those who have merely seen photos can attest to that fact. These lights were coined as Aurora Borealis by Galileo, Aurora being the Roman goddess of dawn, and Borealis coming from Boreas, the Greek god of the north wind. While most people refer to these lights as such, scientists today know them as the polar aurora, because the same phenomenon can happen in the south. The origins of these lights has been debated and studied for thousands of years, although only recently in scientific terms. Hundreds of years ago, many cultures used stories to explain the spectacle. In Norse mythology, it was said that Valkyries, immortal female warriors, would gallop across the sky on their horses, equipped with armor that would glow in the darkness. This glow of colors would spread across the sky, creating the Northern Lights. Alaskan Inuits believed that the lights were the souls of deer, salmon, seals, and whales that they had hunted. Menominee Indians said the lights came from torches belonging to giants living in the north. In the Middle Ages, Europeans thought the lights were a message from God. Even still, other cultures believed that the lights were a warning signal for impending dooms, such as war, death, or fires. Today, the Northern Lights can be explained through scientific terms, but that certainly does not make them any less impressive. The Northern Lights are most often seen as waved ribbons crossing the sky from east to west. In relation to the observer, the Northern Lights are closer to the northern horizon the farther south the observer is located. They are made up of hundreds of parallel rays, creating bands of color that brighten and fade, similar to the flames of a fire. Typically, the lights are pink, green, yellow, blue, and violet, but they can also be orange and white. The direction of the waves themselves is related to the magnetism of the Earth. As seen with a compass, the Earth is like a giant magnet. The magnetic force slants downward into the planet, and the rays of the aurora follow this slant. Scientists know that the auroras follow the magnetism of the Earth because of where they appear geographically. Typically, they are seen in locations about 1,500 miles away from the magnetic pole, an area known as the auroral zone. Closer to or farther from the pole, the aurora becomes more and more rare to see. Scientists have found that Fairbanks, Alaska is an ideal viewing area because of its distance from the pole. In places far away from the magnetic pole, such as Boston, seeing the polar aurora is rare and will only be seen when the sun creates stormy conditions. Near the peak of the 11-year sunspot cycle, the sun sends out a dense cloud of heated gas. The arrival of this gas to Earth's atmosphere disturbs the magnetic environment, creating a magnetic storm. It is this storm that expands the auroral zone to faraway locations. In March of 1989, an aurora spread to the contiguous United States when there was a massive solar storm. It lasted through the morning and was still present in New Orleans when the sun set that evening. These photos are from a resident of Seacliff, New York, a place where auroras would not typically be seen. The lights themselves are caused by electrons colliding with atoms in the upper part of the atmosphere, giving those atoms energy and causing them to give off light. Shades of greens and yellows are given off by oxygen atoms, and shades of reds, violets, and blues are given off by nitrogen. There is about a half to 1 second delay between the collision of electron and atom with the emission of light. The electrons are moving at about 1/10 the velocity of light, so this fractional speed, combined with the momentary delay, explains the lackadaisical brightening and fading of the rays. Each color emitted is found at different altitudes. Those with shorter wavelengths are lower than those with longer wavelengths. This is due to the varying densities of the atmosphere at each elevation. Violet is found at around 60 miles, or at the bottom of the aurora. Greens and blues are seen slightly higher, between 60 to 150 miles. Reds are seen at the top of the auroras, at over 150 miles high. Earth is, as previously established, similar to a magnet, thus it has similar qualities. Like a bar magnet, the magnetic pattern of the Earth follows the same field lines. The lines of the field emanate from the south magnetic pole and converge near the north magnetic pole. From 1895 to 1907, Norwegian physicist Christian Birkeland tried to study the behavior of the auroras. He discovered that these magnetic field lines guide the electrons that make up the auroras, spiraling the tiny particles around the lines as they travel. Ultimately, this ends up guiding the electrons to converge in one place, the auroral zone. In the auroral zone, the electrons do not stop at the end of the magnetic field line, hit the Earth, and disperse as logic would dictate. The ends of the magnetic lines exhibit a strong opposing magnetic force that pushes the electrons back. The electrons get pushed back and forth by the guides of the magnetic field lines to converge, and the push of the magnetic lines ends to repel. When they are being pushed away, they are moving towards weaker fields, causing many of the electrons to be stuck in the upper parts of the atmosphere, colliding with atoms and creating auroras instead of traveling back to the field line's end. This process is known as mirroring. Like anything else in the world, the electrons need energy to travel. The sun provides this energy for them, not through sunlight, the typical way the sun provides energy, but rather through solar winds. Solar winds are emitted by the sun's aura, known as a corona. This glow is always present, but it is especially visible during a solar eclipse. Unsurprisingly so, the corona gets incredibly heated, giving off a gas known as plasma. The plasma is also scalding, so much so that it cannot stay within the sun's gravity. When the plasma has expanded to the point the sun's gravity can no longer keep it in orbit, it blows off, and this is what is known as solar wind. The solar wind cannot penetrate Earth's atmosphere, flowing around the planet and creating a magnetotail where it meets up again. As it travels by, the solar wind transmits electric energy that is mainly found in this tail. Thus, the tail is where most electrons of the polar aurora originate. The electrons flow back to the ends of the magnetic field lines, creating the polar aurora as it has been previously described. As one of the natural wonders of the world, the Northern Lights are a complex phenomenon that has been a fixture in hundreds of cultures for thousands of years. The lights hold many meanings for families, tribes, and cultures, today as well, from connecting to their past loved ones to a beautiful light show in a season of total darkness. With a simple understanding of magnetism, energy, and a few other science topics, it is even more impressive that so many factors can align and create something so incredible.